stone in my shoe. Okay.
Here it is, the stones of Aeolus.
Wow, this is incredible.
If the tales are true, the stone in the centre will have a magical spell inscribed on it in Gaelic.
Ah, I found it. What does it do?
It's said that when the spell is read out loud, the stone circle will come to life. Hang on though, some of it's been worn away. The magic will only work if the spell is complete.
How are we going to work out the missing parts of the spell?
Well, the two missing bits are the circumference and the area, which are both ways of measuring the stone circle. We're going to have to work them out ourselves.
Good job I brought my measuring staff then.
Here are 4 different measurements we can take from a circle. The radius, the diameter, the circumference, and the area. The radius is the distance from the middle of the circle straight out to the edge of the circle. The diameter is the distance from one side of the circle to the other, passing through the centre, and is always twice as long as the radius. The circumference is the distance all the way around the circle. And the area is the size of the space inside the circle.
Okay, so we've got the radius, diameter, circumference, and area. I can easily work out the radius and diameter with my measuring staff, but how do we measure the circumference and area of a circle?
Well, fortunately, I have a couple of runestones that will help us out. This one shows the equation for working out the circumference of a circle, and this one shows the equation for working out the area of a circle. Let's look at the circumference first. The circumference of a circle is equal to pi d, which means that it's pi times as long as the diameter.
Pi?
No, not that kind of pi, but the number pi.
Okay, but how big is pi?
Well, let me show you. We'll place the diameter line underneath the circle and mark the points that are 2, 3 and 4 times as long as it. This is going to help us see how much longer the circumference is compared to the diameter, which will show us how big pi is. We can't use the measuring staff because the circumference isn't a straight line, so let's flatten it out.
Ah, right, that's much clearer. So it looks like the circumference is 3 times as long as the diameter, so pi is equal to 3.
Actually, if we look a bit closer, we can see that it's a wee bit bigger than 3.
Hey, you're right. So pi is equal to around 3.14.
That's right, but it's actually even more than that. It's equal to 3.141. 5, 9, 2, 6, 5, 3. In fact, did you know that the digits of pi never end? There's no final digit, it just keeps going and going and going.
Oh my, how am I going to remember all those digits?
Well, fortunately, we don't need to be anywhere near this precise. You only need the first 15 digits to accurately send rockets into space, so we don't need to worry about all the digits.
Oh, thank goodness. So the circumference of a circle is pi times as long as the diameter, or pi d. What about the area of a circle?
Let's look at my runestones again. The area of a circle is equal to pi r squared, which means that it's pi times as large as its radius squared.
And the radius is the distance from the centre to the edge, isn't it?
Spot on. Let me show you how this works. If we cut the circle up into equal pieces, we can rearrange the pieces into a shape that looks a bit like a rectangle. By cutting the circle up into smaller and smaller pieces, the shape they make looks more and more like a rectangle. Because we haven't added or removed any of the pieces, we know that the area of this rectangle is the same as the area of the circle.
Oh wow, it's like magic. How do we find out the area of this rectangle then?
Well, we know that the height of the rectangle is the same as the radius of the circle, so let's label it r. Now the two long sides of the rectangle are made up of lots of segments of the circle's circumference. So we know that the length of the rectangle must be equal to half the circumference of the circle.
Okay, so the circumference of a circle is equal to pi d. So half of that is pi d divided by 2, isn't it?
Yes, it is, but we can write it in a slightly different way. We know that the radius of a circle, or r, is equal to the diameter of a circle divided by 2, or d over 2. So that means that pi d over 2 is the same as pi r.
Amazing! Looks like we can work out the area of this rectangle now.
Well, the area of a rectangle is equal to its length multiplied by its height. So the area of this rectangle is equal to pi r multiplied by r, or pi r squared.
Hey, look at that! Your runestones were right. The circumference of a circle is equal to pi d, and the area of a circle is equal to pi r squared. I think we're ready to complete the spell and bring the stones of Aeolus to life. I'll start by working out the circumference, which is pi times as long as the diameter, or pi d.
Great, so according to the measuring staff, the diameter of the stone circle is 6 metres.
Okay, so I'm going to multiply pi by 6. That seems simple enough, but I'm still going to need my calculator. I'm going to press the pi button, press the multiply button, type 6 and press the equals button, which gives me 18.849559215.
The spell doesn't need to be quite as precise as that, so we'll round the long number to 2 decimal places. That means the circumference of this stone circle is 18.85 metres long.
Ah, brilliant! I'll work out the area next. The area is pi times as large as the radius squared, or pi r squared.
It's really important to remember that you square the radius first and then multiply the answer by pi.
Got it. If the diameter of this stone circle is 6 metres, and the radius is always half as long as the diameter, that means the radius of this circle is 3 metres. So I'm going to start by doing the radius squared. When we square a number, we multiply it by itself. 3 times 3 equals 9, so the radius squared is equal to 9. Then I'm going to multiply 9 by pi. So on my calculator, I'm going to press the pi button, press the multiply button, type 9 and press the equals button, which gives me 28.274333883. That means the area of this stone circle is 28.27 metres.
In fact, because the area of a shape is a two-dimensional measurement, it's not measured in metres, but in square metres. That means the area of this stone circle is actually 28.27 square metres.
Alright, well, I think we've got everything we need to read the spell and bring the stones to life. I'll let you do the honours, Chris.
Bioich in Carco, Hana Clachenshaw eth Cruchach. Ha Fatch in Oth, Och Diag Pang, Och Kog Mita. Ham Farjingoch, Figasa O, Pang Ya Shak Meter Carnigoch.
Wow, that is breathtaking. Okay, so I'm going to quickly remind myself. The radius is the distance from the middle of the circle to the edge of the circle. The diameter is the distance from one side of the circle through the centre to the other side, and is always twice as long as the radius. The circumference is the distance all the way around the circle, and the area is the size of the space inside the circle. The circumference is equal to pi d, and the area is equal to pi r squared.
Let's play a game. After a quick walk, Will and I have found another spell that will bring 3 more stone circles to life, but like before, it has bits missing. To complete the spell, I want you to work out the circumference and the area of each stone circle. Here's the first one. My measuring staff tells me that its radius is 2.4 metres. What is its circumference and area equal to? If you want, you can pause the video and do it all by yourself, or keep watching to hear Will's answers.
Okay, I'm going to start with the circumference, which is equal to pi d. So on my calculator, I'm going to multiply pi by the diameter. I know that the radius of this stone circle is 2.4, and the diameter is always twice as big as the radius, which means the diameter is 4.8. I'm going to press the pi button, press the multiply button, type 4.8, and press the equals button, which gives me 15.0796447372. That means the circumference of the first stone circle is 15.08 metres long. Now let's work out the area, which is equal to pi r squared. So on my calculator, I'm going to start by doing the radius squared. The radius is equal to 2.4, so I'm going to type 2.4, press the square button, and press the equals button, which gives me 5.76. Then I'm going to multiply 5.76 by pi. So I'm going to press the pi button, press the multiply button, type 5.76 and press the equals button, which gives me 18.0955736847. That means the area of the first stone circle is 18.10 square metres.
Great! Here's the next one. My measuring staff tells me that its radius is 3.7 metres. What is its circumference and area equal to?
Okay, I'm going to start with the circumference again. On my calculator, I'm going to multiply pi by the diameter. I know that the radius of this stone circle is 3.7, and the diameter is always twice as big as the radius, which means the diameter is 7.4. I'm going to press the pi button, press the multiply button, type 7.4 and press the equals button, which gives me 23.2477856366. That means the circumference of the second stone circle is 23.25 metres long. Now let's work out the area. On my calculator, I'm going to start by doing the radius squared. The radius is equal to 3.7, so I'm going to type 3.7, press the square button and press the equals button, which gives me 13.69. Then I'm going to multiply 13.69 by pi. So I'm going to press the pi button, press the multiply button, type 13.69 and press the equals button, which gives me 43.0084034276. That means the area of the second stone circle is 43.01 square metres.
Amazing. Here's the last one. My measuring staff tells me that its diameter is 28.4 metres. What is its circumference and area equal to?
Okay, I'll do the circumference first. On my calculator, I'm going to multiply pi by the diameter. So I'm going to press the pi button, press the multiply button, type 28.4 and press the equals button, which gives me 89.2212311362. That means the circumference of the third stone circle is 89.22 metres long. Now let's work out the area. On my calculator, I'm going to start by doing the radius squared. If the diameter is 28.4 and the radius is half the diameter, that means the radius is equal to 14.2. So I'm going to type 14.2, press the square button and press the equals button, which gives me 201.64. Then I'm going to multiply 201.64 by pi. So I'm going to press the pi button, press the multiply button, type 201.64 and press the equals button, which gives me 633.4707426669. That means the area of the third stone circle is 633.47 square metres.
Brilliant! It looks like we've got everything we need to bring the 3 stone circles to life.
Ah, I'm so excited! You're up, Chris.
Bioich na trí carcú hana Clockinshaw cruachach. Ha umlan na othin un kiak figus sa shak pang kog meter ugach. Ham farjingoch imlan shia kiet naigit a kieth pang kog meter carnigoch.
Would you look at that?
It's a beauty.
Okay, so I'm going to quickly remind myself one more time. A circle has a radius, a diameter, a circumference, and an area. The circumference is equal to pi multiplied by the diameter, or pi d, and the area is equal to pi multiplied by the radius squared, or pi r squared.
Yeah, you've got it. These magical formulas are so useful because circles are everywhere in our lives. Whether it's the shape of a drinks cup, wheels on a car, or even these stone circles, they all hold mysteries just waiting to be discovered.
Wow, I don't think I'll ever be able to look at a circle again without thinking about all the magical secrets it's hiding. Thanks, Chris. If you want to keep practicing, download the worksheet in the video description, which includes the chance for you to uncover a magical spell and see a brand new stone circle come to life. There's still more magical secrets to uncover. This Celtic knot symbol is hiding somewhere in the video. Can you find it? Tell me where it is in the comments below. If you like this video, make sure to give it a thumbs up. Subscribe to learn more science, English and maths with Will, and let me know what you want to learn next by commenting below or emailing info@learnwithwill.co.uk.